Hello and welcome to my tutorial on how to implement A-star algorithm on spherical meshes. This implementation will work on any complete mesh, so it'll work on a cube or a pyramid or anything that doesn't have edges that aren't joined together. So this would not work on a plane. By the end of the tutorial, we will have an implementation like this. So when we click on a point and we click somewhere else, a path is generated in order to get to that point. And this is using A-star algorithm in order to calculate the path. So if we just pause here and go into the scene view, we can see the path being generated on each of these triangles. We have a path node in the center. So I'm just going to go over quickly, very briefly, how A-star algorithm works, and then we'll jump into the code. A-star algorithm is the most commonly used algorithm for pathfinding in games. Given a start node and a finish node, it can calculate a path in order to get to the finished node. In a 2D space here, we can see how it will work. We have these grayed out boxes that indicates a node that is blocked and the algorithm will not be able to pass through. And here we can see it calculates the shortest path in order to get to its final node. In a 2D space, A-star algorithm will have 8 neighboring nodes in which it can traverse to. It will choose this node based on its f cost, which is equal to its g cost plus its h cost. G cost is the movement cost to move from the starting point to a given node. For this position to this position will be more expensive than moving from here to here, as it is diagonal. And the h cost is the estimate movement cost from any given node to the final node. So if our starting node was up here and our ending node was here, it would calculate the estimated cost from this node to this node using a heuristic function. In order to implement A-star algorithm in a 3D space, we'll be using a mesh's triangles in order to populate a path node in the center of each of these triangles. A given path node's neighbors will be defined as any triangle that shares a vertex with the given triangle. So in the case of our green triangle here, our neighbors will be here, 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 and here. We can define the cost of moving to any of these path nodes by the distance of our path node to the location of our given path node. So without further ado, let's jump into the code and see how to implement this. Okay, so here I am in an empty Unity project, and the first thing I'm going to do is I'm just going to create a 3D object for us to work on. So I'm going to create a sphere here. And one thing to note before we go ahead is that this implementation is only going to work on a object with a scale of 1, 1, 1. The basic reason behind that is because when you create one of these 3D objects, it starts off with a vertex position for each of these triangles, and then it needs to know where those triangles are in order to scale it up their original position. So if we scale this up, then the original positions of these vertices are still going to remain the same. So you could do some matrix multiplication to figure out where they're going to be, but yeah, just know for now that our scale needs to be on a 1, 1, 1. So we're actually going to get rid of this sphere collider, and we're going to add in a mesh collider, which just gives us a nicer mesh that we can work on, as you can see here. Okay, so first script we're going to make is we're going to come over here into our project. I'm just going to create a new folder for our scripts. And our first script we're going to call path node. And this script is going to be responsible for holding all the information for our individual path nodes for the node network we're going to create here. So just go ahead and open that up. Okay, so here we can just get rid of our start and our update method, and we don't need to inherit from mono behavior. Okay, we're going to need a few values to store in here, so we're going to have a public int for the index of this path node. We're going to have a public vector3 for the position. And now we need to store some values that are going to be used in the algorithm. So we're going to have a public float for the g cost, And I'm not going to go too in depth here, but the G cost is basically the total cost that it's going to take to move from one node to the next for the algorithm. And here we're going to have the public float H cost, and the H cost is it's the value for how far it is from a single node to the end goal of our algorithm. And then we're going to have a public float F cost, which is the total cost of the G cost and the H cost combined. And then we're going to need to take a public path node, and we're going to call this the came from node, which is the node in which this particular node came from. And then we're going to set up a constructor here. So we're going to say path node. So if a lot of this doesn't make sense right now, don't worry, we're going to be implementing the algorithm later, and hopefully you can see how these values are used. So here we're just going to say this.index is equal to index, and this.position is equal to position. We're going to need one more function in here. We're going to say public void calculate fcost. And here we're simply going to say fcost is equal to the gcost plus the hcost. Okay, and that's everything we need for our path node class. So if we go back into Unity, we can create our second script here. And I'm going to call this script node network. And this is going to be responsible for managing our network of nodes, plus we're going to have a few functions in here that's going to populate and allow us to access some dictionaries to our nodes here. So here we go, we're going to open up our node network, and we're going to need a few things. We're actually going to need our start method here, so if we just remove our update. And we're going to need a public mesh collider. I'm going to call this my mesh collider. And we're going to also need the mesh that is stored inside of that mesh collider. So I'm going to create a private mesh, just call it my mesh. Okay, and now we're going to need a dictionary. I'm going to make this static just because I know there's only going to be one instance of this, and it's going to make it a bit easier to access from other classes. And we're going to have ints for our keys, and they're going to store path nodes for the value. I'm just going to call this path nodes, and set that equal to a new dictionary, like so. Perfect. Okay, so if we come down into our start function here, we're going to set up my mesh equal to my mesh collider dot shared mesh, which just gets the mesh that the mesh collider is storing. And now we're going to need to create a function that's going to populate all these values for our path nodes. So let's come down below here, and we'll just create a new function, call this private void populate path nodes. There we go. And here we're going to do a for loop, and we're going to say for int I is equal to 0 as long as I is less than my mesh dot triangles dot length. And my mesh dot triangles just stores an integer array of triangles that's basically a pointer into the vertices. It might not make a lot of sense right now, but just know this for loop is going to loop through all of the triangles in our mesh. And when we're doing this, we actually need to plus equals by 3. And here we're going to set up some values we can store. So we're going to say vector3 vert1 is equal to my mesh dot versus my mesh dot triangles of I. I'm going to copy this down twice here. And I'm going to say vert2 and vert3, and here we need to add by 1 to get our second vertex, and plus by 2 to get our third. So right here I'm just going to say loop through all triangles in my mesh. Okay, so what we're going to do is we're going to loop through all of these triangles in our mesh, and we're going to find the center point of each triangle, and that's where we're going to create our path node. So to do so, we'll come back into our script here, and we're going to have another vector 3. I'm going to call this center point, and we're going to set this equal to our vert1 plus vert2 plus vert3 divided by 3. And this just gets us the center point between all of these 3 vertices. So then down below, we're going to create a new path node, call this new node, and we're going to set that equal to a new path node with I for the index and center point. So the reason we're setting the index to I is this is going to make it very handy later on, because we're basically setting all of our nodes their index is going to be the same index as their triangle here. So this path node's index is going to be the same index as this triangle, and same for this one, and so on and so forth. And in the future, that's going to make it much easier to manipulate and do some stuff later on. And then we're going to come down below, and we're just going to say path nodes.add I and new node. Okay, so now if we come into our start function, and underneath where we've initialized my mesh, we can call populate path nodes. And then just to give some visual feedback here, we can come down here and say on draw gizmos, we'll set our gizmos color, so we'll say gizmos, equals to color, and we'll set it to green. And then we'll say if path nodes does not equal to null, and path nodes dot count is greater than 0, then we're going to loop through all of our path nodes. So we'll say for each path node in path nodes, and here we need to say dot values because we're looping through all the values of the dictionary. And we're going to say gizmos dot draw sphere at a position of node dot position, and we'll have to make this quite small because we're working on a scale of 1. Well, not that small. We'll say, oh, there we go, 0.01f. Okay, so now if we save this and we return to Unity, and we'll just need to make sure we've got gizmos turned on here, and if we hit play, oh, we'll get an error actually, because, or not an error, but we've not actually created an object to store our node network script here. So we'll create an empty game object. Let's call this node network, and we can drag our script onto that. And here we say, see it takes in a mesh collider, so we can just drag our sphere onto our mesh collider, and now if we hit play, oh, of course, this is the problem with working on the of our scale of 1 to 1 here. We actually need to recenter this sphere, so I'm just going to reset the transform. So like I said, if you do need to have this working on objects that aren't going to be centered and don't have a scale of 1 to 1, you can do some just matrix multiplication, or just offset the path nodes by our transform here. But for now, I'm just going to work in the center. So here we can see we have a node that is generated in the center of each of these triangles. And we can manipulate these nodes in order to use a star algorithm. So the next step that we're going to need to do is we're going to store each of the neighbors of each of these triangles here. This is something that the algorithm needs to know. It needs to know which nodes it can go to. So what I'm going to do is we're going to have 12 neighbors for each node, and we're just going to say whichever triangles share the same. If a triangle shares any of the vertices in a given triangle, so let's say for instance this one, if any triangles share this point here, so that would be you know, this triangle, this triangle, this triangle, and we'll see the same for this point here. That'll be this triangle, this triangle, this triangle, and then that's going to be a neighbor. So we can basically go here, we can go here, we can go here, we can go here, and yeah, and so on. I feel like that's the best way of doing this, just to implement solid paths around the sphere. So yeah, that's how we're going to do it. So we're going to come back into our script here, into our node network, and we're going to set up we're going to first create a new dictionary. And this is going to have, again, ints for our key, but this time we're going to store an int array, because this is going to store an array of integers that point to a path node that we can use up here. So we're going to call this our neighbor nodes. And just make sure we change that to an int array. Okay, so down below here, we're going to create a new function. Call it private void populate neighbor nodes. And here we're actually gonna return a list. A list of integers. And yeah, we're actually gonna store this as a list as well. We could store this as an array, but yeah, just for easiness, I guess we're gonna store this as a list. Which will make it easier in the future when we're having to add and remove stuff from our nodes. Okay, so here down below in populate neighbor nodes, we're going to create a list of ints, and we can call this result nodes, as this is going to be the result, and we'll set this equal to a new list of ints. Okay, now this is actually going to take in an int for our current node that we're looking at here. And we're going to set up some values here. So we're going to say a vector3, and we'll say this is our current vert1, and this is going to be equal to my mesh dot vertices my mesh dot triangles of our current node. So this is basically saying that we're gonna give it in a current node, like we're gonna pass in one of our nodes from our list here, and this is gonna get one of the vertices of that triangle. So the first vertex is gonna be this value here, and then if we copy this down twice more, we're gonna say vert2 and vert3, and again we're gonna come over to here and we're gonna add 1, and here we're gonna add 2. Okay, so I'll just say here store vertices of given triangle. So our current triangle we're looking at here, this is what these values contain. And now we're going to do a for loop here, and we're going to loop through all of our triangles. So we're going to do mymesh.triangles.length, and again we're going to have to plus equals by 3 because we're iterating over the triangles. And we're going to store some values in here as well. So we're going to say vector3 vert1 is equal to mymesh dot triangles, dot vertices of my mesh dot triangles, and here we're going to take in I. Copy this down twice more, and again we're going to add by 1 here, and we're going to add by 2 here. So basically this is just storing the values for the vertices of the triangles we're looping through, because remember we're comparing each of these triangles to the to all the triangles in the mesh to find out what the neighbors are. Okay, so I'll just say here store values for, I guess, for triangles we're comparing against. For triangles we're comparing against. Okay, so down below here, we're going to say if first of all, we need to make sure we're not comparing against the triangle that we're giving in here. So to do that, we're just going to say if I is not equal to current node, then we may continue into this loop here. So we're going to say if current vert1 is equal to vert1, or current vert2 is equal to vert2, or sorry, I'm going to do it like this, or current vert1 is equal to vert3, then we can basically say this is a neighbor. But first of all, just to do an extra step, just to make sure that we're not going to get any errors here, I'm going to say if path nodes dot contains key of I, and that's just going to make sure that our dictionary up here, path nodes, actually stores the of the value we're looking at. Otherwise, we might get some errors that say the dictionary does not contain the key that we're trying to access here. So then we can say result nodes dot add our value of I. And we're gonna have to do this twice more because right now we're just checking our first vertex here. We need to do the same for these two here. So I'm gonna go ahead down here. I'm gonna say else if. I'm just gonna copy this line here. I might skip ahead here. It's just a lot of copy and pasting the same code. Okay, so here we have now just here's the code. So we're just comparing all the first vertex here against all the these the triangles we're looping against. Then we're comparing the second vertex and then the third vertex, and we're adding the neighbor to the result node here. So if we come down after we have finished this loop, then we can just return our path nodes or our result nodes. There. Okay, nice one. So this is gonna populate all of the triangles, and you might see here. So if we call, well, let's not call it here because this is gonna take a very long time. Okay, because we're basically saying we're looping through each of these triangles, and for each of these triangles, we're looping through all of the triangles. So that's obviously not a very efficient way of doing things. So we're gonna jobify this code using the Unity's job system. That's gonna massively increase the time here. If we call this method right now, it would take a very long time. So we're gonna do that probably in the next tutorial. But for now, we're just gonna set things up so we're ready to go. So we can do a little example here. So if we come up here, we can maybe create a new function. Call this populate. Did I already call that populate neighbor nodes? So I'm going to call this populate all neighbor nodes, but right now we're not going to populate all neighbor nodes. We're just going to populate the first one. Oh, fine. So what we're going to do here is we're going to call populate neighbor nodes, and we'll just give in 0 right now. So we're basically just populating, we're just going in and we're finding the first triangle and we're finding its neighbors is what it's going to do, and it's going to store this in this dictionary. So right now if we come down to our ongizmos draw, we can just change this a little bit here. So I'll comment this out for now. And we'll say if, what do I call this again? Neighbor nodes. If neighbor nodes is not equal to null, and neighbor nodes dot count is greater than 0, then we'll say for each. What do we need to do while we're here? Remember, we're storing a list of integers here, so we're gonna say for each list of ints I in neighbor nodes, remembering to put dot values. Then, so we're looping through all these values, and then we say for each path node j in, or well, this will just be for each int j in I. Then we will draw a gizmos dot draw sphere at a position of path nodes j. That'll probably be that position, right? Yep. And size of 0.01f. Okay, so what this is basically doing is, remember, we've only populated the very first triangle's neighbors. So in here, we are just drawing the a little sphere at all of the neighboring nodes for the first triangle. So let's save this and just make sure that works. Okay, so we're back in Unity here, and if we hit play, oh, did I call? Let's see here what's going on. We didn't actually call populate all neighbors, so below here we'll call populate all neighbor nodes. Now if we return to Unity, save that, let it compile. Okay, hold on 1 second. Okay, yep, of course. Here we actually need to say our neighbor nodes. What do we need to say? Well, this is returning a list. So right now here, I guess we say neighbor nodes value of 0 is going to equal populate neighbor nodes. Is that right? Or, sorry, we'll say neighbor nodes.add. This will be a cleaner way of doing this. Neighbor nodes.add an index of 0. Populate neighbor nodes 0. Okay, now if we save that, that should work. If we return back into Unity, and we hit play, and as we can see here, this is clearly where our first triangle in the collider here was. So our center point will be around here, and this is all the neighboring nodes that you'll be able to traverse to from this node here. Okay, so you can maybe already, as I mentioned before, you'll have a bit of a problem here because this function should be responsible for populating all of the nodes here. So what we should really be doing is, I'll just comment this out, is saying for each, what will we say here? Well, we'll be looping through all the path nodes. We'll say for each, I guess, int I in path nodes dot keys, or just path nodes. Does that work? No. Yeah, we need to look through the keys. So we're looking through all the keys of our path nodes here. We're going to populate the the neighbor nodes. So we'll say neighbor nodes dot add a value of I with populate neighbor nodes I. And this is going to take a very long time to run. I wouldn't recommend running this unless you have a minute to spare. But yeah, because we're having to loop through every single triangle. Well, for every triangle, we're looping through every triangle, so it's not exactly very efficient. So that's why we're going to use Unity's job system so that we can run this function on multiple threads and massively increase the speed. And the reason we want to do this at the very beginning, because what we could do is we could just get the neighbor nodes. We could run this function whenever we need to obtain a neighbor node, but that's not a very clean way of doing things because in the long run that's actually going to take longer. Because during runtime we're basically having to loop through all of the triangles and figure out which one. So I think it's a much cleaner way if we store this at the very beginning of our game in a list, and then we can just reference into that list to find out the neighbors. That's going to be it for part 1 of this tutorial. It's already a bit longer than I expected, but in part 2 we will be implementing the functionality for the A-star algorithm, and I hope to get that out as soon as possible. So thanks again for watching, and I'll catch you in the next one.